Please open up your textbooks to page 172. We are going to be completing extension 4.3, Areas of Composite Figures. So first off, a composite figure is made up of triangles, squares, rectangles, and other two-dimensional shapes. On this page, we see a couple of examples. You'll notice that these shapes could be broken apart into two separate shapes that we can find the area of. The first one, if I draw a line across where the dotted line is, you'll notice we have a rectangle and a triangle. You already know how to find the areas of these two individual shapes, so you would calculate each one independently and add them together. In the second figure, you'll notice that we have a square and a trapezoid. Same thing. You find the area of each shape individually, add them together. There is not a formula for finding the area of a composite shape all at one time. You have to break it up into smaller pieces. Okay, sometimes those composite shapes might be on grid paper. So here's an example of a problem. It says find the area of the purple figure. Well, once again, we can start by breaking this shape up into two that we recognize. If I drew a line across, you'll see we have a rectangle and a trapezoid. Okay, once you have each individual figure, you can find the area of each individual piece. So on this one, my rectangle, I have it 4 units across and 6 up and down. So the length times width, 6 times 4, would give me an area of 24. So I'm going to go ahead and label that on my rectangle. It is 24. Then the trapezoid. If you take a look, the base is 8 and it is 2 inches high. So we need base 1 and base 2. It doesn't matter which is which. So here's my, I'll call this base 1, and it has a length of 4. I will consider this part to be base 2, and it's already labeled with an 8. So when I apply that to my formula, 1/2 the height of base 1 plus base 2 means that I'm going to do 4 plus 8 is 12. Multiply it by 2, and that gives me 24. And then remember, you can either multiply it by 1/2, or if you prefer, and I'm going to just mark this because I do prefer working with whole numbers instead of fractions. Remember that the same thing as multiplying by 1/2 is dividing by 2. So you can choose which way to do it. If I take my 24 and divide it by 2, I get an area of 12. So the area of the purple figure, I'm going to have 24 for the rectangle, and for the trapezoid it's 12, and that gives me a total of 36 square units. Now, oftentimes in real life, we're going to have shapes that are composite figures. Take a look at this example. We have what is considered to be a fairway at a golf course. Most of the shapes that we deal with in real life aren't always perfect rectangles or squares or triangles or trapezoids or parallelograms. They're combined shapes, and we need to decompose or break them apart to find the area. So this shape right here, they've sketched out, and you'll see that it can be broken up into a rectangle and triangle. If I go over on the actual picture, notice if I draw a line here, I get a rectangle and a triangle. So what they did is found the height, or the area of the rectangle. Remember, length times width, so 70 times 40 is 2,800 for the rectangle. And then the triangle, 1/2 of the base times height, is going to give us an area of 600. If you add the 2,800 plus the 600, that gives us a total area of 3,400 square yards. Now, you can either write square yards as it is, or you can choose to do it in the opposite order and just say yards squared. Means the same thing either way.